Today we're actually going to solve equations using the change of base formula. Now from yesterday, this is what the change of base formula is. Now basically, why do we use the change of base formula? Because our calculator only operates in base 10. Okay, the 10 comes from the fact we use 10 digits, 0 through 9. And so if I had a logarithm that wasn't base 10, say for example base 3, I could not evaluate that using my calculator because this number here, this little 3, has to be a 10. Okay? And so what we have is we have the change of base formula, which allows us to convert this to base 10, and then we can find an answer. So change of base formula basically means that you're going to take the log of whatever the big number is, in this case 4. Now when I say big number, I don't mean biggest. What I mean is size-wise. Okay, size-wise here, if you look, n is the biggest number because a is a subscript. Okay? Divided by the log of 3. So whatever number is here will go first on the top. Whatever number is a will go on the bottom. So if I just divide log of 4 by log of 3 on my calculator, that will be what this logarithm is approximated to be. So now, we're actually going to look at how you solve equations. So if you look at this, it says 4 to the x equals 19. So there is a way to solve this, and you could actually use trial and error. Because you know that x has to be greater than what whole number? What does x have to be greater than?
4.
Not 4.
5?
2.
2. Why does that have to be greater than 2? Because what is 4 squared? 16. So it's got to be a hair bigger than 2. Okay? And so there is a way, though, instead of using that guess and test and figuring out what it has to be, and that's by using the logarithm. So what I'm going to do is I'm going to do this. I'm going to take the log of both sides. Okay? I'm going to take the log of both sides. So really what ends up happening is I have like log 4 to the x equals log of 19. Now we got a problem with that power, right? But the beauty of this problem is that with logarithms, anything that's an exponent like I have here, what I can do is I can take that exponent and move it around front. So that's what I'm going to do. And so really what that means is that I've got x times log 4 equals log 19. So can somebody tell me how I would solve that then for x? Divide by log 4. Very good. So on the left side, what ends up happening is they cancel. And I've got x equals. On the right side, I need to calculate log of 19 divided by log of 4. So you did this yesterday. So on your calculator, I need you to take log of 19 divided by log of 4. And when you do that, what do you end up getting? 2.123. So let's round that to make it look like money. So 2.12. And there you go. So that's what we're doing today. Okay, so now let's go ahead and look at this one. So what are we going to do to both sides? Take the logarithm, yep. So I'm going to take the logarithm of both sides. So I end up having log of 3 to the x equals log of 15. What do I do now? What do I do now first? I bring down the x first. Okay, so I really have x times log 3 equals log 15. Now some of you might be doing this on the first step. You can bring that x down as well, and that's fine. So really, now I'm going to divide by log of 3, and what does x equal? Oh my goodness, you already got the answer? Okay, so just a second, let me go ahead and write this out, especially for those kids that are watching it 5th period today. So log of 15 divided by log of 3. And what do I get x to equal? 2.46. Questions? Yep. All you're going to do is take the log of 3. Yep. Okay, so let's go ahead and look at this one. Now, this problem is no more difficult than the one we got done looking at. It's just got one little step we've got to add in. So what do you think the very first step is going to be to do? Take the logarithm. Yep. So I end up having the log of 2.1 to the a plus 2 power equals the log of 8.25. What do you think you're going to do now? Take the a plus 2. Pop it right there. So you have a plus 2. Now what I'm going to do is put that in parentheses. Oops. All right, what do you think you're now going to do? Divide by log of 2.1. Perfect. So far you've done everything correct. So what am I left with on the left side? A plus 2. Very good. On the right side, I need to use my calculator and take log of 8.25 divided by log of 2.1. What do I get there? 2.84. Somebody else get that?
Yep.
Okay, so then now I need to solve for a, so what do you need to do? Subtract 2, and there you go. So what is your final answer going to be? 0.84. There you go. Questions? All right, let's look at this one. So what do you do first? Log. So I'm really left with log of 7 to the x squared equals log of 20.42. What do you do now? Move the x squared around front. Very good. So I'm left with x squared times log of 7 equals log of 20.42. What do you do now? Divide by log of 7. So really I end up getting x squared to equal what? 1.55. What do you do now? Take the square root. What is the very important thing you always need to remember when you take the square root? The plus or minus. Very good. So x equals plus or minus 1 point, somebody get 2.4?
2.5.
Is it
Yeah,
1.25?
Yep.
Okay, there you go. Questions? Alrighty, what's different there?
There's one on each side.
There's one on each side. Can't cancel out. Yes. Okay, so very first thing you're going to do, take the logarithm again. So you've really got the log of 11 to the x minus 3 equals the log of 5 to the x. What do you do now? Move the x minus 3. Yep, you move them both. Very good. So move those both. So really I have x minus 3 in parentheses times log 11 equals x times log of 5. Now, normally when we solve this, we would go ahead and divide by log of 11. And we could do that. I mean, if you wanted to do that. All right, you want to do that? Or the other thing is we could just approximate what each of these is. Yeah, what is the log of 11?
1.04.
1.04? Okay. What is the log of 5? 0.70 or point?
It rounds up to 0.7.
Okay, 0.70. So let's revisit what that means. Okay? What that means here is that I'm going to take 1.04 times each of those. So really, you have 1.04x minus, yep, 3.12, and that's going to equal 0.7x. So how do you solve that? You bring the x's over, yeah. I could bring the 1.04 to the right so that I don't have to move the 3.12. So I end up having negative 3.12 equals negative 0.34x. What do you do now? Divide by the negative 0.34. Good. And what do you get x to equal? Point what? Somebody else get 9.18? Very good. And see, that's the nice thing about logarithms, especially these, is you don't all have to solve them the same way in order to get the correct answer. We got one more to look at, and then we're going to call it good. Actually, I take that back. We don't have one more to look at. Okay, here's your assignment. What I want you to do is add that to the assignment from yesterday. Those of you that were not here yesterday, your assignment was to do, on the same page, 16 through 21 and 33 through 38. So those of you that were gone, you need to add these problems as well as the ones that I have written there. Now, we're going to shoot for these all being due Monday. Okay, they are due Monday. Got it?